Okay, this is a heck of a question here. We have a regular pentagon, and we want to imagine that in terms of adding vectors, if we added AF plus BF plus CF plus DF plus EF, that we would get the zero vector. Now the fact that these are all midpoints is going to help us out quite a bit. What we're going to do to answer a question like this is we're going to try and think of taking different paths from point to point like roads on a map. In other words, instead of going from A to F, we're going to say, what if we went from A to G and from G to F? And we're going to try different things, and we might not get it right on the first try. We might not figure out which different paths we should take to answer a particular question, but with experience you tend to develop ideas. So to go from A to F, we're going to say let's go from A to G and from G to F. And to go from B to F, we're going to say instead let's go from B to G and from G to F. So to add AF plus BF is kind of like adding AF plus BF is kind of like adding AG plus GF plus BG plus GF. So in other words, the GFs, we can collect those like terms and call it 2GF. And you might wonder what happens to the AG plus the BG. And we realize that they cancel each other out. AG travels this way, BG travels this way. Since G is the midpoint on this line segment, these two vectors are opposites, and they cancel each other out. So we can say that AF plus BF is equal to 2GF. AF plus BF is equal to 2 of these GFs. Alright, well, by a similar token, we can say BF plus CF is 2 of these HFs. And CF plus DF is 2 of these IFs. DF plus EF is 2 of these JFs. And EF plus AF is 2 of these KFs. So what we've got now are 5 distinct equations. What we're going to do is add them all up. We're going to add all the left sides and add all the right sides. On the left side we have AF plus BF plus BF plus CF plus CF plus DF plus DF plus EF plus EF plus AF. And if you collect all those like terms, what you really get is 2AF plus 2BF plus 2CF plus 2DF plus 2EF. That's what you get on the left. On the right hand side, it's a little easier to see. You get 2GF plus 2HF plus 2IF plus 2JF plus 2KF. Okay, well, what you might notice is that GF right here is the opposite of DF. So in other words, GF equals negative DF. And similarly, HF is negative EF. IF is negative AF. JF is negative BF. And EF is negative HF. And so now, what we can do is call, since GF is negative DF, we can call this negative 2DF. And we can call this negative 2EF. We can call this negative 2AF. And we can call this one negative 2BF. And we can call KF here, we can call KF negative 2CF. And so what we get is an equation 2AF plus 2BF plus 2CF plus 2DF plus 2EF equaling negative 2DF minus 2EF minus 2AF minus 2BF minus 2CF. We got that from subbing in these to this equation. And we get this equation right here. And now what we can do is see that we have like terms on both sides. So for instance, let's add 2CF to both sides. That'll eliminate it on the right and make 4CF on the left. And if we add 2BF to both sides, it'll eliminate it on the right and make 4BF on the left. And if we do that all the way through, we see that we get 4AF plus 4BF plus 4CF plus 4DF plus 4EF equals 0. Now we can see an opportunity here to factor out number 4, and we get 4 times AF plus BF plus CF plus DF plus EF equals 0. Divide each side by 4, and we realize that we've proven exactly what we were asked to. So ultimately the moral is you want to try different paths from one point to another, and then see if you have an opportunity to cancel out vectors that are negatives of each other. That approach will often get you the right answer.